All right, so BC squared, I think I wrote this on the board yesterday, is the same as BC times BC, right? So we need to identify two triangles that have the sides BC and then again BC, CD, and CF. Okay, so like I said yesterday, because there are two BCs, BC is going to have to be the common side between the two triangles. So this one here, that is going to have to be a side in both of our triangles. So it's going to be the bottom triangle and then also the big triangle. But if you don't recognize that, you can do your kind of checking, right? So you can look at, let me rewrite this in black. So we have BC times BC equal to CD times CF. I just want us to do this checking across thing. Right, so you're going to look at the first two sides. Which letters do I have there? B, C, and D. Is that a triangle? B, C, D? Yes. Okay, so we're going to work with B, C, D. That combination of sides does make up a triangle. And then we're going to look at B, C, F. B, C, and F. Those are the letters that appear there. Is B, C, F a triangle? Yes. All right, so those are going to be the two triangles that I'm going to work with. So we're going to say in triangle BCD and triangle BCF. All right, again, if you're struggling to see how to prove that these triangles are similar, list the three angles underneath the name of it. So I'm going to write BCD. And if you don't need to do this, don't worry. You can prove that these triangles are similar sometimes without listing them. Just makes it a bit easier. So for the whole BCD, I have all of angle B, which we can see is a 90-degree angle there. And then I have angle C and I have angle D. But then in BCF, which is this triangle here, I have B1 and angle C and angle BFC. All right, so now we're going to match up the ones that are equal, and we can hopefully see straight away that angle C is common. It's an angle in both of them. And then, guys, angle B and angle BFC are also equal because they are both given as 90-degree angles. Right, so those two angles are equal. And then for the third pair, we're just going to say that they are equal because of angle sum and triangle. All right, so number one, we're going to say angle C is common. And remember, the order in which you put your 1, 2, 3 doesn't matter. So you can write those in any order. The thing that is important, though, guys, is this one, this pair, you have to write last. Okay, the angle sum and triangle pair must go last. You can't say angle sum and triangle and then C is common and then B is equal to BFC. All right, because you first have to show that two pairs are equal, and then because of that, the third pair will be equal because of angle sum and triangle. So this dotted line one always has to go last. Okay, but the other two you can write in any order. Okay, we said that angle B was equal to BFC, and that was given because they are showing us in the picture that those two angles are equal to 90 degrees. And then lastly, we're going to say angle D is equal to B1, and now that is because of angle sum in triangle. Okay, therefore, triangle, and now we can use the same order that we have in our proof here, CBD. So triangle CBD is similar to triangle, and now we're going to use the same order but on the other side, CFB, and our reason is angle, angle, angle. And now we can do our fractions that will allow us to get this equation, the equation that they asked us to prove. All right, so we need a BC, so let's go with this BC here. It's the first two letters, so then I'm going to need the first two letters there, right? So I'm going to say BC over CF is equal to, all right, so I already have a BC and I have a CF. What else do I need? I need another BC and a CD. All right, so where am I going to get that from? There I have CD, and then that is going to give me the second BC. So CD over BC. Guys, what you can also do, which is probably just easier, is to write all three fractions, right? If you don't feel like figuring out which two fractions to work with, you can always write all three down, and then in your final line, choose the two that you need to work with. Okay, so that will always give you the marks as well. The reason for that is similar triangles. And now to get what they've asked us to prove, which is this up here, we are just going to multiply the two denominators out. Okay, so this BC in the denominator is going to go, and I'm going to multiply it with the BC on that side, which is going to give me BC squared. And then here I have CD, and I'm then going to multiply the CF on the other side.